Then see, directly you just note down these results, these two results. Next to two signals, e power minus at sin omega naught t u of t. If you remember, in Laplace for sin omega t we have written omega naught by s square plus omega naught square. If there is e power minus at, this s has become s plus a. Correct? Same thing you just notice here. Omega naught as it is, that omega naught square as it is, s is j omega. Next one, in Laplace for cosine omega naught t, omega naught by, sorry, not omega naught, s over s square plus omega naught square. Then for this e power minus at, s plus a, here s plus a the whole square. Then you substitute s equal to j omega, you will get a plus j omega, here a plus j omega the whole square plus omega naught square. Same equation. Okay? Shall we go for the next one? So you just note down this signal, e power minus a absolute of t. E power minus a absolute of t. See, when I write absolute of t, what is the meaning? It takes both positive values and negative values. Okay? This is time axis 0. This is positive and negative. When t is positive, e power minus at. So how it will be? Is it exponentially decaying signal? When t is negative, already there is a minus, e power at. So will it be an exponentially growing signal? Okay? So can I write like this? F of t is e power plus at into u of minus t plus e power minus at u of t. Okay? So apply Fourier transform. So f of omega. What is the Fourier transform for the first equation? E power at u of minus t. Is this the result? 1 over a minus j omega plus second one. Simplify this. So cross multiply a plus j omega plus a minus j omega a square plus omega square. So this j omega you can cancel. So Fourier transform of e power minus a absolute t, this is equal to 2a over a square plus omega square. Okay. Next function, sine function. So some people call this as signum function. Signum, sine, both are same. Okay. Sine function. See, this is how the signal will look like. For positive values of time, it is 1. For negative values of time, it is minus 1. At time t equal to 0, it is 0. So this will look like a step. So sine of t is 1 for t greater than 0, minus 1 for t less than 0, and 0 for t equal to 0. This type of signal is called signum or sine function. Okay. So before finding Fourier transform of this sine function, you just note down a result. Fourier transform of u of t. This I will be proving. Okay. Next, just note down this result. Fourier transform of unit step function. You just note down this. 1 over j omega plus pi into delta omega. Two things you have to note down. One is Fourier transform of unit step function. Have you taken this? Second one, you just note down this time reversal property. If the signal is time reversed, that means f of t is time reversed to f of minus t, the corresponding change in the frequency domain is f of minus omega. So these two things are important to solve this problem. Note down this. This is basically a property of Fourier transform. F of minus t is f of minus omega. Have you taken this? See now, first step what I am doing, I am writing the sine function in terms of unit step function, something like this. Sine of t is u of t minus u of minus t. Okay. I'll write here. Sine of t is u of t minus u of minus t. We'll verify this. What is u of t? From 0 to infinity it is 1. This is u of t. Right? U of minus t. Minus infinity to 0, it is 1. U of minus t. Sorry, minus of u of minus t. The amplitude will be inverted. Now what you do, you perform this operation. U of t, this signal minus, no need of minus, already we included minus here. So just add these two signals. So what will happen? Here left hand side from minus infinity to 0, this is 0. Whereas this signal is minus 1. So from minus infinity to 0, I will get minus 1. Whereas from 0 to infinity, this is 1. From 0 to infinity, this is 0. So if I add these two things, you will get a signal like this. Sine signal. Okay. First step. Then we know the Fourier transform of u of t, which is 1 over j omega plus pi into delta omega. What I am doing, I am just applying Fourier transform for this entire equation. We know that Fourier transform is linear. So right hand side, Fourier transform of u of t, Fourier transform of u of minus t. Okay. So Fourier transform of u of t is u capital omega minus Fourier transform of u of minus t, time reversal property. See here, this is reversed. So in the frequency domain, it is u of minus omega. So I know what is u of omega. U of omega is 1 by j omega plus pi delta omega. That I am substituting here. Then there is a minus. Then u of minus omega, wherever omega is there, that I will be writing with minus omega. Is it clear? I know u of omega equation. Wherever omega is there, I am just writing minus omega. Simplify this. So pi into delta omega. Okay. Then this 1 over j omega. This minus pi into delta minus omega. This minus into minus plus 1 over j omega. So we know that just now in today's class only we discussed this impulse signal is even function. So delta minus omega is delta plus omega. You can write. So first term and second term gets cancelled. These two terms if you add, you will get 2 over j omega. So two things you should know. One is what is the Fourier transform of unit step. Second one, the time reversal property. If you time reverse f of minus t, the corresponding change in the frequency domain f of minus omega. So omega you will be writing as minus omega. Additionally, you are using linearity property. So Fourier transform of sine function is 2 over j omega. Okay.